Let's learn about similar figures. Hey buddy, now I might just be an eyeball, but eyeball. On our agenda today, we're going to review solving proportions. We'll notice and wonder. We'll compare congruent with similar. We'll prove two triangles similar, and then we'll use proportions to find side lengths. So you're going to need a calculator for this, and we're trying to solve for x. So this is a proportion where we have one fraction equal to the other. Most of you are going to jump in and cross multiply, but I want to show you why cross multiplying works. So I want to multiply both sides by 4, and then 4 over 4 is going to simplify to 1, and I get 5 equals 4x over 12. Then I'm dividing by 12, so I want to multiply both sides by 12. So I get 60 equals 4x. Divide both sides by 4, and we get x to be 15. So yes, you can just cross multiply, but the reason it works is because you're multiplying by each denominator. If you have more than one term in the numerator or denominator, I would suggest parentheses. So I'm going to multiply, and I have 6 times 5, which is 30, and then 12 times the parentheses, x plus 2, and it's an equal sign in the middle. I'm going to distribute my 12, so I get 12x plus 24 equals 30. Subtract the 24 from both sides, and we get 6. Be careful, make sure you're dividing the right way. I want to undo the 12, which is being multiplied by the x, so I'm going to divide both sides by 6. The answer is not 2, the answer is 1/2 here. And one more, just has 2 binomials here, so I'm going to put both in parentheses, and I will cross multiply to get 3 times the group of x minus 5, and 2 times the group of x plus 4. We distribute on both sides and then solve. So I'm going to subtract 2x from both sides, and I get x minus 15 equals 8. Last is to add the 15 to both sides, so x ends up equaling 23. So what do you notice here? We have the cozy coops, big, one little. What do you notice here? My little Lego man. So we're trying to get at the idea of similar. We've spent some time with congruent, and we know that congruent means that all of the corresponding angles and sides are congruent. We remember the congruent sign is the equals with the squiggly over it. And we have just proven two triangles congruent using 5 different methods: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. If we have all of those things, then we can prove the triangles congruent to each other. However, similar's slightly different. So similar means that all of the corresponding angles are congruent. So the corresponding angles, they still have to be congruent. But now the corresponding sides are proportional, and that's why we just practiced setting up those proportions where we'll figure out which thing goes with which, so we can write the proportion and solve for unknown sides or angles. Sides. Congruent versus similar. So we have a new symbol here, and it's just the squiggly. You don't need that equal sign anymore. How do we prove two triangles similar? We only have 3 ways. So remember that angle, angle, angle did not work to prove two triangles congruent? Well, angle, angle, and I'm going to put the little squiggly there for similarity. Angle, angle, similarity says if 2 angles are congruent to 2 angles of the other triangle, then that is enough to say that they're similar. SSS means that all of the sides are in the same proportion. They're not congruent anymore. They're all in the same proportion. And then side angle side similarity means 2 of my sides are in proportion and my angle is congruent. Let's take a look. So are these 2 triangles similar? Well, I have 3 sides, but I need to make sure they're all in the same proportion. So I'm going to match up 15 and 30. And that reduces to 1/2. I'm going to match up 20 and 40. And that simplifies to 1/2. And then 25 to 50. And that simplifies to 1/2. So because they all have the same reduced fraction, they are in the same proportion, and therefore it would be side, side, side similarity that proves these two triangles similar. Let's look here. AC is 5, CD is 13. Okay, well, it's not congruent, and I don't have anything else to compare numbers to see if they're proportional. But I do see that I have parallel sides, parallel lines, and those are going to hide congruent angles. So I have this angle is congruent to this angle by alternate interior angles. And then if I go the other direction, that angle is congruent to that angle by alternate interior angles. And just having two angles congruent is enough to say that they are similar by the angle-angle similarity. Are these two similar? Well, we have two angles. We remember our triangle sum theorem that says that the angles have to add to 180. So if I do 180 minus 79 minus 60, I'm going to get 41. Well, that doesn't match up to 42, just slightly off. So no, these are not similar. So just be careful. They both have to add up to 180 still. Are these two triangles similar? Well, let's see. I do see my 50-degree angle is congruent. And now we have to pay attention to how they match up. Are these rotated onto each other? Are they just slid onto each other? So this 12 is my smaller side compared to the 24, and the 8 is my smaller side compared to the 16. So it kind of is just a straight, it's not a twisted relationship here. So I'm going to do 12 is to 8, and I'm going to simplify that. 4 goes into both. So we get 12 divided by 4 is 3, 8 divided by 4 is 2. So it simplifies to 3 halves. And then I'm going to compare 24 to 16. 8 goes into both. So then that means I get 3 halves. The two corresponding sides are in the same proportion with an angle in between them congruent. So these are similar by side, angle, side. We can also use similarity and proportions to find missing sides and angles. So if I'm looking for the question mark here, this is just a slide. I could slide the little one over. So 3 corresponds to the 9, the 4 corresponds to the question mark, and the 5 corresponds to the 15. So I'm going to name my question mark X, and I'm going to say 3 is to 9. I like to go from one triangle to the next, matching up the corresponding sides, as 4 is to X. So we're going to cross multiply, and we get 3x equals 36. When we divide, we get x to be 12. In this example, it is just another direct slide. You can see I have my congruent angle with the 1 mark, and then I have 2 marks. So I know that I already have angle, angle, and these triangles are similar. So I'm going to match up the 24 with the 16. So I have 24 over 16 equals 21 over x. So when I do that, I'm going to get 24x equals, and 21 times 16 is 546. Divide by 24, and you get 22.75. That's okay. It doesn't have to be an integer. And on this problem, so I can see I have right angle. I have this little 1k is congruent to angle M. And so that means that the 3 is going to go with the U, and the 5 is going to go with the 10. I also know because those are my hypotenuse. So I'm going to say 3 is to U, that's little triangle to big triangle, as 5 is to 10. So when I cross multiply, I have 5u equals 30, and therefore u equals 6. So just to recap, similar figures have congruent angles. Similar figures have sides that are in the same proportion, and we prove similar using angle, angle, side, and side. Nice job.